So this is the second organic chemistry set of questions, the longer answer questions, question 2. So we have a compound X, this is very common in organic questions, and we're given an empirical formula of CH2 and given information that the molecular ion peak has a mass of 70. So if you're not familiar with that, that means that basically the relative molecular mass, the MR of the molecule, is 70. And we know that the empirical formula, the simplest ratio, is 1 carbon to 2 hydrogens. So what we need to do is work out the mass of CH2, which equals 14. And then we do 70 divided by 14, which gives me 5. So the empirical formula needs to be multiplied by 5, giving me a molecular formula of C5H10. So the next part tells me that compound X reacts with bromine in an addition reaction. So even though I've already got a clue, so C5H10, that's a general formula of CnH2n, which suggests this is an alkene. The fact that it reacts with bromine in an addition reaction is a more backup for this idea, because it could be a cycloalkane with that formula as well. And so the balanced equation simply needs to be C5H10 plus Br2 makes C5H10 Br2. It's as simple as that. Don't want to be drawing any displayed formulae or anything like that, because we don't actually know what isomer C5H10 is. We're going to be looking at that later in the question. So compound X also reacts with steam, and so again this is just another addition reaction. It says certain conditions because water doesn't add to an alkane normally under room temperature. It would be using a catalyst and high pressure, but the point is you could write C5H12O. Even better if you were to write C5H11OH, and the reason for that is you're just showing an understanding that you're making an alcohol, that you know that when you add water, steam, to an alkene, the hydrogen adds to 1 carbon, the OH group adds to another, and you're making an alcohol. But the top version, C5H12O, is perfectly good enough to get you the 1 mark. Then we're told that compound X exists as 2 stereoisomers, which is why, incidentally, I happen to know that it's not pent-1-ene, so it can't be double bond at the start of the chain. So it has an E and a Z form. So I know it's got 5 carbons and I know it's got a double bond. I've only got 3 carbons left. I can't have pent-1-ene, so if I start trying to draw, for example, a skeletal formula, so 1, 2, 3, 4, 5, there's my 5 carbons in a row. If I were to make it pent-1-ene, then I would have 2 hydrogens on that carbon there, so that doesn't have stereoisomers. What about pent-2-ene? Pent-2-ene does. So if I just put the double bond on the 2nd and 3rd carbons, then if I were to look at the carbon on the left of the double bond, it's got a methyl group and a hydrogen atom, and the other one has got an ethyl group and a hydrogen atom. And so it turns out that those are my 2 stereoisomers. Anything else I try and do, so there are other isomers of C5H10. The other option, so I've already moved the double bond, is I could move a carbon and make it shorter. For example, 2-methyl but-2-ene, but just have a look at that and you can see that there are 2 methyl groups on that carbon, so that doesn't have stereoisomers. So it turns out that pent-2-ene is the only option that has stereoisomers. So I'm going to draw pent-2-ene. That would mean that there's 1 carbon a methyl group, and then I'm just going to simplify the rest of it as C2H5. So you can see I've got 5 carbons in total, and then the other atoms would be hydrogen, and then the other isomer would be with both the hydrogens on opposite sides and the methyl and ethyl groups also on opposite sides. So draw the E and Z forms. Done. Let's label them. So E would mean that they are across from each other, so that would be this form here. Z would be that they're on the same side. In this case we can just look at the hydrogens. The name of the molecule is just going to be pent-2-ene. So far we've got 3 marks, and it says explain the 2 conditions, so very clear where the next 2 marks come from. 2 conditions which give rise to this type of isomerism. So this is just really explaining what we mean by EZ isomers or how they arise. So we need to say there is no rotation around the CC bond, and just write it like that is fine, or no free rotation or cannot rotate around that bond. And the other condition is that there are 2 different groups, i.e. methyl and a hydrogen, ethyl and a hydrogen, on each, that's quite important, carbon of the double bond. So not just 2 different groups on the double bond, because that doesn't work. If you might have 2 different groups, but then there would be 2 of the same thing on 1 carbon. And then we have compound X reacting with steam. The product also contains 2 structural isomers. So why would that be? Well, compound X, I'm going to go back to doing a skeletal formula. Compound X was pent-2-ene. And so this is a bit like the HCl question that we had where we were adding to, in the multiple choice, to the diene. So the point of adding steam, which is H2O, is that you're going to add H to one of your carbons and OH to the other. So there's an option of which way that adds. And so even though there's only 1 double bond, your option is that the OH can either end up on that second carbon or on the other side of the double bond in the middle. So there's my structures. It says draw the structures. Drawing the structures means that you can do skeletal, you can do displayed, you can do structural formulae, it doesn't matter. So I'm going to call that one pentan 2-ol. So it's pentan now, not pentene, because it's now saturated, we've lost the double bond. So don't call it pent 2-ol, be careful about that. The 2, because the OH group is on the 2. And then this would be pentan 3-ol. So fairly generous, as long as you get it, work out what's going on. You get 4 marks for 2 relatively easy structures and 2 relatively easy names. And then, very last bit, the mixture of Y and Z was then reacted with acidified potassium dichromate under reflux. So I have, doesn't matter which one's Y and Z, we're not expected to know because there's no information to tell us that, but I've got pentan 1-ol and pentan 2-ol and pentan 3-ol. I'm just going to oxidise them, and they're both secondary alcohols, so I can't make a carboxylic acid because the OH is not on the end of the chain, so I'm basically just going to make 2 ketones like that. That's not answered the question though, so be careful. It says name the 2 organic products. That would be called pentan. Remember to keep the an in whenever the ene isn't there. Pentan 2-one, and that would be pentan 3 O.